In this video, we're going to look at another stunning question of Cartesian planes, reductions, identities. It's all packaged here and ready for us, and so let's dive straight in. So in the diagram below, we've got a point P, which is K24. Immediately, I'm going to drop a line 90 degrees to the x-axis. So K represents the x value, 24 is the y value, and before I even read any further, I'm going to just do Pythagoras in reverse to get the other side. So that equals 49, and the square root of 49 is plus minus 7. But in this case, because I can see that I'm in this quadrant where the x is negative, I'm going to choose the negative 7 option. And so 5.1.1, we've done that. Then any questions to do with theta, we're always allowed to look from the origin angle of the triangle. And so if they ask me what is tan theta, I can just immediately look here and see tan is opposite 24 over adjacent minus 7. Careful not to write k there. I don't need to get too excited and start shifting, which some people do. Only if they ask me to work out theta itself, I would shift. Otherwise, I just leave my answer like that as a fraction. Now things come a little bit left field, and they say find sine A if theta plus A is 360. And so what you'd want to do here is first just get A by itself, because then the question of what is sine A, if you know A is 360 minus theta, then you can replace sine A with 360 minus theta. This just becomes a normal cast diagram reduction where 360 minus theta is in the fourth quadrant. It doesn't belong to sine, so it's going to be negative sine theta. And then again, I can just look in my picture and say, looking from the origin, what is sine? It's opposite over hypotenuse. And so your answer would just be negative 24 over 25. 5.1.4, if they say what's cos squared theta minus sine squared A, be careful of which is which, because they've got different angles they're looking from. And so cos squared theta, I can look in the theta picture, and cos is adjacent, so minus 7 over hypotenuse squared minus sine A, and we've just worked out that sine A was what we worked out here, and that answer left us with this. And so sine squared A would just be this answer squared. And that leaves us with an answer of negative 527 over 625. Then moving on to 5.2, I'm going to do it up here. It's a completely different question. When I see these angles, I want to always try and do two things before I begin. The one is look and see if there's any big angles like this one, because if they're big angles, and by big I mean bigger than 360, I'm just going to minus 360 to fix it up. And so at the bottom here, this will just become cos 60 before I've even begun to think too hard about reductions. Secondly, if I see any angles that are too small, like this one, then, and by too small I mean a negative angle, I'm just going to add 360. And so if I add 360 to this, this just becomes sine 300. And so look out for those just for starters. Are there any angles too big or too small? So now when I come to the actual reductions, I'm asking myself, which quadrant is it in, and is it positive or negative, and how many degrees is it to the nearest x-axis? And so cos 210, 210's about here, that belongs to tan, so cos is negative, and how far is it from the nearest x-axis of 180? It's 30 degrees away. Keep things in brackets to be safe. Tan 315, that's about there. That's the cos quadrant, so it will be negative tan. And how far is 315 from the nearest x, which is here at 360? It's 45 degrees. Sine 300, that's about here, and so I'm in the cos quadrant, so sine is negative. And how far is it back? It's 60 away. Be careful if I'm in this quadrant not to think that I must now start writing cos because it's in the cos quadrant. You're just looking where the thing you have is positive or negative and how much, so it will still be the same unless you applied co-ratios where you change sine to cos. We'll see if that comes up in this video. And then lastly, we've got cos 60, which that is now just reduced. And so what you've got for starters is you've got a lot of negatives, so let's just cancel 2 of them, and then there's 1 negative left, so we know for the rest of the question the answer will just be a negative. And then each of these will just be something from our special triangles, and so you can use your calculator. And so if you are stressed in the middle of exam, it's totally fine to use your calculator, but it's ideal if you can, like I'm doing, and as quickly as I'm doing, fill in the angles and the sides. I would do it at the front page of my question paper in, like you've seen, 20 seconds as soon as you get your question paper. So when you get to this cos 30, so I look from 30 and it's adjacent over hypotenuse, so that's root 3 over 2. Tan 45, looking from 45, tan is opposite over adjacent, so that's just 1 over 1. Sine 60, so I go to the 60, sine is opposite over hypotenuse. And lastly, cos 60 is adjacent over hypotenuse. If you like, you could summarize the top line, and so that's just negative root 3. I'm timesing the numerators and then I'm timesing the denominators, and then I'm going to tip and times this. So on the bottom denominator here, I've got 4, but I'm going to tip and times, so it will now be at the top. And on the top here, I've got root 3 times 1 is root 3, but I'm going to be flipping the fraction. And so that's what I end up with. And the root 3's cancel. 4 cancels with 2 and leaves me with just minus 2. And that's your final answer. And then the last question for this video, 5.3, we've got a identities question. And so what's jumping to my mind immediately is that there's a tan, and tan squared is 1. And I'm just going to write it like this. You'll understand why in a sec. Tan squared, so it's 1 divided by tan squared is just sine squared over cos squared minus cos squared, and I'll just put that over 1. Why did I put it as 1 divided by this? To remind myself that it's going to tip and times, and it will flip and become cos squared over sine squared minus cos squared over 1. Then what's buzzing in my mind is that I've got fractions all of a sudden, and when I've got fractions, I want to look for the LCD. And so the LCD between these two terms is sine squared. So this cos squared doesn't need anything, but this cos squared needs a sine squared, and so it will be cos squared sine squared. Then any time in maths when you're feeling a bit stuck and it's getting a bit hectic, and you're tempted to make cos squared 1 minus sine squared, but just leave it for now, especially seeing as where we're going. We've got the LCD worked out perfectly. The final answer is sine squared, so we just need to give a bit of love to the top. And so if I take out a cos squared, I'm left with 1 minus sine squared. And what is 1 minus sine squared? It's just cos squared. And so I've got cos squared times cos squared, which is cos to the 4. And that is the identity proved. I hope that you found that video helpful. If you did, please like it, subscribe to our channel, and share this with your friends. Thanks.